पिताजी करते हैं तो पिताजी को पता है ना कि कितनी मेहनत लगती है। चलो ये तो अच्छी बात है। वेरी गुड।
Now, we'll be starting our today's session. And at the end of session, I think most of the non-parametric test will be over. And I hope that almost you have an idea of what kind of study to be taken, what kind of sample size to be taken. So before I start the rest of the non-parametric test, if anyone is having any confusion, we can take with that. Let me start with the one, the study which one wants to take. The person is having homeopathic medicine. He wants to find out whether the arsenal is effective in prevention of COVID-19 or not. In such case, initially you might have done observational study that thousands of
recording.
I hope all of you can able to listen, right? So I'm talking about the person who wants to start those who do not want to speak, please keep mute. So I'm talking about the person who wants to do whether the arsenal is effective or not in COVID-19. So I suggested that it would be better to have an observational study first. That means already thousands of people took arsenal, right? And whether they had suffered or not, there is one thing you can observe that. But then there could be another thing that you can have a cohort. One cohort you give a arsenal 30 to one cohort, other cohort you don't give a arsenal, and compare over a period of time. Let's say 6 months, 1 year, like that. 1 year is ideal. And find out in both the groups how many cases of COVID-19 occurred. But the cohort study will not have that much the power as a randomized control trial will have. So what that person should do, that there should be volunteers who would like to undergo this trial. Let's say we want to specify whom you are going to. Are you going to give to newborn? Naturally, no. So you define your population that you are going to give between the children having age of, let's say, 5 years and up to the age of 50 years or 60 years, like that. In that population, tell them whether you are ready to undergo this kind of trial or not. If yes, then you will be given either the medicine, arsenal, or other placebo. And then every 15 days or every 1 week, you will be followed up whether you are developing a particular disease or not. Now, because it was homeopathic medicine, I suggested that instead of going for the investigation and prove that it is, yes, it was COVID-19 or not COVID-19, instead of that your philosophy is based on the symptom complex, then why not to register symptom complex rather than going for the pathological test? Yes, if you want to do it, you can do it. But even if you do the symptom complex, that is sufficient. So let's say every week you are going for the COVID-19 test or just symptoms. If symptoms positive, then you go for the test. That is also possible. But in this case also, suppose you have taken, let's say, total 2,000 population, you are randomized into two groups, 1,000 here, 1,000 there. And then you are giving a placebo, one group, and another group, arsenal 30. In that case, then every week you are following up. So those who develop a symptom, you can find out whether that was COVID-19 or other disease. And those who were not having symptom, in that also subsample you should take for the purpose of COVID-19, because that could be a carriers without any symptom, but they might have the viruses still could, you may be able to find out. So this kind of study, randomized control trial, person can do it for 1 year or maybe for the specific period of 3 months where the maximum likelihood of the transmission is there. So such kind of study, at least you should take one study. Now, if someone is having a quick question, we can take up that. Otherwise, we'll switch over to the non-parametric test. Whatever we have left out, that we'll be talking about. Any quick question? I hope all of you have read the various kinds of non-parametric tests which I have shared. Any question? Okay, so let me go towards. Now, we had already covered Mann-Whitney test. Now, today we are going to talk about Wilcoxon sign rank test. Here, there could be a positive or negative. Both are taken into consideration, and whether it was significant or not. Because sometimes, because of your treatment, the person may feel better or sometimes may feel worse. So, this is the test which will take into consideration positive effect and negative effect, and then ultimately which one was more, and then whatever was the result, whether it was significant or not. This is a test which will be useful to find out the results based on your the intervention. Let's see. This we have already seen. The Mann-Whitney test. Now, in this Wilcoxon sign rank test, you just need to remember that it is a basically non-parametric test. And just like when you, in your t-test, you are doing the various kinds of procedures in which you are finding out the combined standard deviation, and then you are looking at the t-value. And here in this case, we will be finding out the W value, and we'll compare with the tables. Just like a Z table, T table, chi-square table, we'll have a W table also. And when we want to compare the two sets, for example, we have 10 patients or 20 patients or even 7 patients, and we want to find out before and after. Even you can say you had the 10 students in this, few people were sent for the yoga before, and you are testing the before pulse rate and after pulse rate like this, or before the therapy and after therapy. Same population you want to compare. In that also you can use this. And W plus means positive difference, improved, and negative difference means it reduces. There's the condition worsens. And there will be two W's, W plus and W minus. Out of that, the smaller will be able to use while looking at the table. Now, it may take 1 or 2 minutes, but then we need to read this. And similarly, I wish that in all our setup, at least this kind of study you should be able to formulate. And when we are teaching around 8 to 10 people, at least someone will be coming with this kind of thing. A pain researcher is interested in finding methods to reduce lower back pain in individuals without having to use drugs. So there is no medicine, you are not giving any medicine, and still you want to relieve the pain. And you want to find out whether it is effective or not. Here the person is want to use acupuncture. And sometimes you may give a vitamin D and calcium. Sometimes you go for the exercise like that. In this case, the researcher recruits 10 participants in the study. At the beginning of the study, the researcher asks the participant to rate their back pain on a scale of 1 to 0, with a 10 indicating the greatest level of pain. So pain is very severe, 10 marks. If a pain is a very little bit, very low, it's a 1, like that. So initially, if the patient says that it is a 7, and then after patient says that 4, that means there is some level of reduction of the pain. Here the number is relative to the quantity, more the number, more the pain. After 2 weeks, he asks again to indicate the level of back pain on the same scale. He wishes to understand whether the participant pain levels change after they had undergone the treatment. So let us look at the result. And in this case, first says that there are 10 patients and rating before therapy 5, and the after 4 weeks says 2. That means there is an improvement, that is a +3. Second is 8, then the after 4 weeks 4. That means there is improvement by 4. Similarly, but in case of 4th patient, if you look at this, then they said that 4 pain, but because of the acupuncture, it has increased to 7. So effect is -3. So I hope that plus and minus you will be able to understand. The next thing is the sign +3, +4, etc., x minus y, that also you can understand. But this absolute value, this is the most important thing which you should understand. The absolute value, you remove the sign, plus and minus, and you just write the absolute value. So far, it is not difficult at all to understand this. But this next step is important to understand because here you are giving a rank. So the lowest is 1. So you are giving rank 1. Then there is the next one, 2. So you are giving the rank 2. And another 2. So that is a rank 3. After that, there is a 3, so rank 4. Then another 3, 5, another 6, like that. And then the still 1 is hidden. That is also 3, is a 7. And then 4th is 8. Then the another 4th is 9, like this. So this you are giving a rank to it. And if it's possible, so the 6th is the 0, so 0 is not having any rank. So similarly, I repeat that we start with the lowest figure. There's a first, there's a rank 1, second is rank 2. Again, if it is 2, you should not repeat with 2. Give it a rank 3. But then, when you go for the average of the rank, so for example, 3 is rank 4, but another 3 is 5, another is 6, another is 7. So if we make a total of the rank for the 3, 4 plus 5 plus 6 plus 7, that is 22. So 22, 3 are coming for 4 times. So 22 divided by 4, that will give you 5.5. That's why against this 3, if you look at this 3, 5.5, this 3, 5.5, and this 3 also 5.5. So if you look at the 1, it is 1 because only 1 was there. If you look at the 2, here it is 2 as well as 3. So 2 and 3 average is 2.5. So against the absolute value 2, it is written 2.5, 2.5. So you are giving a rank to all of them. And once you are clear in giving a rank, again go to original sign, positive or negative. So here you are taking a sign plus 5 plus 8 plus 2. It was a minus. So minus 5.5 plus 5.5 like this. This is how you are going to rank the sign. And now only the number of person, rating before therapy, after therapy, sign, and the minus or so, all are very clear. But this absolute value also very clear. Only thing you should keep a little bit concentration on how to give a rank from 1 to 9, because your 1 was 0. And then rank you have taken as an average and assign the sign. Now in the sign rank test, you make a total of both, plus, 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 and minus. So let us see what is the total. So here the W plus is 33 and W minus 12. That means in this, if you add 5.5 plus 8.5 plus 2.5 plus 5.5 plus 8.5 plus 2, then it will be 33. And if you make a total of minuses, then it is 12. So out of these two, plus 33 and W minus is equal to 12, out of this you go for the minimum value. And this minimum value is 12. So this much is very clear. Now what does it mean this W means? So we need to go for W table. In this W table, our sample size was, this is N, samples was 6, 7, 8, 9, it was a 10. And the critical value was 8, as if we are finding out in Z is equal to 2 like that, right? Here the critical value was 8. And in our case, what happens, that look at the 12, right? While the test is 12 and critical value is 8 for total P of 0.05, the test statistic must be less than this to be significant at this level. So in this case, the null hypothesis is not rejected. So we accept the null hypothesis, there is no significant difference between these two. So in this case, look at this 0.5. Suppose it was, instead of 8, if we can find out, then we could have said that it is significant. No?
I don't know why.
The reason I will tell you, we are going for minimum. Minimum the level, most will be the significant. You can see that in 8, in 5, if you go in that direction, is more and more significant, it is seen. It is not like Z, when it is Z is more, is P is less than like that. So here, between the two, 33 and the 12, we go for the minimum value. The more the minimum, more it will show the significance. And that's why we say that, suppose instead of 8, if it is the 5, we say that significance is 0.02, while at 8 is a critical for 0.05. If it is still less, at the same sample size, it will still more significant. So this is a 12, figure of 12 says that it is much higher than the critical value. And we say that it is null hypothesis will accept and will say that there is no significant difference between these two. So the person who says that my therapy is very important will not accept that, because the W has said that it is not significant. Now the calculation of this W tables and Z table and all those things is for the statisticians to do this. For us, it is interpretation is important. If we can go for 33, then it is of no use. That's why we go for the minimum. And we will not go for another example because it is the same, and you will be given in this file. Already I have shared this file with you, PPT. So you can go through the second example also. So if you have any question, you can wait on this, else we'll move ahead. Okay. So you should know about how to read this table. Suppose it was, let me ask you one question. The sample size is 12. Sample size is 12. And the minimum W was 3. Sample size 12, minimum W was 3. What will you call it? Significant or not significant? Just either you spell out or write in the checkbox. I say that minimum W is 3 and sample size n is equal to 14. Now, is this difference significant or not? Is it significant? Right, significant? Significant or not significant? Somebody said significant. Anyone else? Any other answer? So this is a very simple table. Will tell you that at n is 14, the critical value is 21. Now, if your W is less than this, that means it is significant. If it were more than this, it is not significant. This is how we use Wilcoxon sand rank test. So we go to the next test. Another interesting thing is it will take only 10 minutes to understand, but for the purpose of a very small group data, the chi-square will not be useful. And so we go for this Fisher excess test. It's very simple formula. And the Kramer-Sweet test and 5 coefficients. These 3 things I will be sharing file with you. Now the Fisher excess test, when the chi-square test is not that helpful because of a small samples, small numbers, at that time you should be using this. It has the formula, it gives directly the p-value. Now, you know this 2 by 2 table is miraculous. So you forget this part, a b plus upon like this. You just remember this right side thing. This a plus b, c plus d, a plus c, b plus c. All the 4, that is the exclamation mark you have, right? And below that, a, b, c, d, n is a total. Now, this formula gives you direct probability. And based on p-value, you'll be able to say whether it was significant or not. In this case, I hope that you recollect 5 exclamation mark means 5 into 4 into 3 into 2, like that. So this 5 factorial or 3 factorial that you have learned in the maths classes. Now here, in this example, once you go through this example, the exact test will be, this Fisher's exact test will be simple. In your chi-square test, you are doing observed minus expected value squared divided by E, while in Fisher's exact test, we directly calculate like that. So here we have, so only few people are there, brand A, brand B user, male and female. Whether this significant difference between male and female, between two brand or not? That is the question. So what we are doing over here, you have this subtotal 3, 7, 6, and 4. All you are taking factorial over here, divided by, then you are taking direct factorial, this 2, 4, 1, 3, and multiply by n factorial 10. In this case, this 3 and 3, 4 and 4 are related. And so naturally it will be F2, F1, F10. And here F7 and F6. So here F7, that means 7 into 6 into like that. Here we already distributed over here. This is a multiplication sign and this is multiplication sign. So when you do 10 factorial, 10 into 9 to 8, then 7. 7 and 7 factorial are deleted. And if you look at the rest of the thing, it is 120 upon 140, 240. So is 0.5. So probability of this occurring by chance is 0.5. So it's more than 0.05. So we can say that there is no significant difference between the choice of male and female. If you directly look at over here, you can say 33% over here and then 25% over here. But this is not significant as per the Fisher's exact test. So any question on this? So now we'll be going for the another coefficient, that is a Kramer's V and phi. Name are unfamiliar, but the formula is very simple, is for the purpose of correlation coefficient, whether there's an association between two variables or not. And for that, we need to calculate chi-square. And here the chi-square is divided by, if it is a Kramer's V, divided by n, that means the total number, into k minus 1. K is the number of column or number of row. Whichever is low, that is taken as k. Suppose if you have a 3 column and 4 row, then you go for 3 column. So 3 minus 1, that you are taking. So in this case, while in phi, we always has at least 2 column or 2 row. That means 2 minus 1. That's why is only difference between Kramer's V and phi, because this phi is used for a smaller number of row or column. Now in Kramer's V, this is a formula, and we just will apply in some kind of the example. And because it is an association, you will get this file, so no need to write. Between 0 to 1, if between 0 to 0.29 is a weak association, if it is 0.6 to 1 is a high association, and rest in between. So this you can find out the association between two variables. And in one example, chi-square values is 84.9, and then you have 3 by 4 table, that means k is equal to 3. And then if you consider this, and total number of the sample is 430. So the value is V is 0.31, that means moderate association. And chi-square test, probably all of you know it, and that will be given by the computer also. And then you can find out V like this. In case of phi, you just remove the k minus 1, because in this case, we take only 2 by 2 cross tabulation. So in phi, because it's 2 by 2 tabulation, 2 minus 1 is equal to 1. So the same formula, but it is only n. So in this case, one example, let's say chi-square is 19.5, n is equal to 40, then your value is 0.69. In this case, you can say that is a moderately strong association. So these 3 tests are very small tests, and if you have any question, we'll wait for a few seconds. Otherwise, we'll go to the next thing. Any questions so far? So just you can write understood or partially understood? It is someone. These three things, famous V test, and exact test, and the phi test. Okay, not considering the response is not understood, and we'll go ahead. So this is now, suppose you have 100 villages or thousands of villages, and you want to find out whether the vaccine coverage is proper or not, whether the people are happy or not, or whether the people are taking diabetic treatment or not. For that matter, we have the loss quality assessment sampling technique. And this loss quality sampling technique, we have two slides. One on the Excel file on the will to for your the sampling technique, and other the interpretation. I'm starting with the interpretation, but then we'll come back for the sampling. This is very simple. Only thing you need to understand that if you have taken 19% in the sample, I repeat, from the whole 100 villages or 10 villages, or let's say 400 classes, you are supposed to take only 19 individuals, 19, that's all. And out of 9, if over here I say if 7 are saying that yes, we are having a vaccination, for example, you are sure that the vaccine coverage is not more than 50%. It is a very, very simple to interpret and very fast. I repeat, suppose if you are taken a sample of 21, right, and you say that 8% are vaccinated, right? So you can say that here again a 50%, if the coverage is not more than 50%. So whatever you take, usually we take 19. And out of 19, if suppose answer is that 12% are having vaccination or 12% are taking regular treatment, let's say there are population of 9,000 adult population. You have taken a sample in loss quality assessment technique. Only you took a 19 hypertensive cases. Out of, you find out that 12% are taking regular treatment. That means you are sure that, and 7 are not taking. That means you're sure that not more than 75% are covered with the regular treatment. So you should concentrate 1 minute on this, that on this size the sample size and decision rule for sample size 20 to 30 and coverage benchmark or average coverage of 10 to 95%. Coverage benchmark or average coverage. It gives you average coverage. If suppose out of 19, there are 6 are covered, the coverage is around 45%. If out of 19 diabetic patients, if 10 patients are taking regular treatment, you can say that usually 65% people are taking regular treatment. This is how we arrived at the interpretation. Now, in this case, how we are going to take sample? Because you need to take a sample size, right? So next Excel file will give you how to derive the sample. You are given another file. This file you can open up and the programming is already done. You need to just copy and paste your village population over here. And once you write down your village population over here, this is the original file. And you just need to write down your population over here. You need to write down your villages over here. I can change a little bit. For example, you can say that you can name your village over here. You can copy paste your village also here. And you can copy paste your population over here. Like this. So if you are around 10 villages, you can copy your 10 villages over here. If you are 100 villages, you can copy your 100 villages over here. If you're 1,000 villages, you can copy your 1,000 villages over here. This is how you are going to work. And your population you should be writing over here in this column. So suppose you have a list of population somewhere. Your list of villages, and here have population. And from this population, and you just copy it over here, and then you can paste over here in this case. If you do this, then automatically cumulative sample and sample will be shown over here. You forget about this cumulative sample or forget the cumulative population. You are given directly that you need to take one sample, one person, you need to choose from village this. Right. Another your sample is, this automatically is calculated. This is your second sample. And the sample which is denoted by this is to be taken randomly from that village, as if you are taking from the cluster sampling technique. You are taking randomly from that village. Instead of using the village, you can use the classes also. Class 1, class 2, class 3, you are working with a university and you have around, let's say, 900 classes. Out of that, you want to take only 19 individuals and you want to find out whether they are getting enough health services or not, or whether they are having addiction or not. If such kind of prevalence, if you want to find out, you require only sample size of 19. And from the 19, when you ask the question and then find out the answer, and based on that, you go back to your this rule table, LQAS rule table, and from this, you can find out what will be the coverage of the university classes or in the population, etc. Very simple technique. Immediately you can apply and you can find out what will be the coverage. So any question on this? And I expect all of you to apply this method, at least hypothetically, where you can apply this method. Any question on this? Will you be able to use this technique? It is basically started from the industry. Industry of first lot, second lot, third lot. So from all the lots, they need not take the sample, right? So they approximately take one from the 2-3 sample, one another plots like that. And from that, out of the 19 samples they check, and they have to pass this at least, they decide the standard. They whether to go for 50% or 75% accordingly. They may go for, let's say, 85%. So if they say that out of 1914 are passing, that means 85% are passing, like that. This is how they use this technique. And if they want to go for, let's say, the 95% are sure, then they will see that out of 19, minimum 16 should match the standard. This is how the industry decides. And the same technique we can use for the community health. So finishing that, now we'll come back to the discussion that how all these tests can be applied in your setup. You just tell me your setup and we'll come to the idea that how this can be useful. you tell me any kind of your population or sample, etc. And we can use a different kind of sampling techniques, as well as we can use various analytical tests. And your data should be gathered in such a way so that you can apply most of the tests. This is for the learning purpose. So any question? So if there's no question, then you should talk about your project. What is your population? What is the sampling technique, etc. Because our next session will be basically we should be discussing about your projects, that whether it fulfills all the criteria or not. Dr. Akshada, can you tell me about your project? Or not taken so far?
So the project is not ready yet.
But then you just tell us what is the field of work. From that we can find out. We can help you to find out. What do you do?
So last time I had told this idea about anti-rabies vaccination.
Yeah, that you can go ahead with that. But then suppose if I want to tell you that you want to, suppose you want this lots quality assessment sampling technique, how you can use it in your setup? So I will tell you that in a village, see, this is a sampling technique, right? You'll have 100 villages name will be with you. You have the population, you just copy and paste in this, and you will be able to find out which village you should be taking. In that village, you just need to find out randomly one person having a dog bite. But instead of one person, let's say you in last 1 month, how many had dog bite? You find 4 or 5 people. Then 5 out of the 5 people, simple random sampling technique, you can select one, right? So only 19 such cases rabies you take, and you just ask the question whether you had sufficient vaccination or not for the rabies. And suppose out of that says that out of 19, let's say 7% says that yes, we had taken vaccines. That means that around 50% coverage would be there, like this. So this is how you can use this technique, right?
Okay, sir.
So this anything what about Dr. Neil? Will you be able to use Kramer's V test? Yes or no? If you have a very small sample, then you can use the whether SOC is there or not. Right? What about Dr. Randhir Kumar? Were you using any such non-parametric test, sir? Dr. Randhir Kumar, are you using any such non-parametric tests in your day-to-day life?
No, sir.
So will you be comfortable to use now?
Yes, we can.
You are a teacher. What do you do?
Yes, sir. I am assistant professor at IGMS Patna.
So suppose you have a very small sample, in a small batch of 22 students. You have a two kind of things, regularly attending, non-regularly attending. In that, whether they pass or fail. Suppose this is the very small data. In that, you can see that the regular attending and pass or fail, whether there is an association between these two or not. So the statistical eye or epidemiological, basically, once we learn it, we apply in our own setup. Then
Yes.
It will be much better. Anyone else? So all the participants are, unfortunately, we have only 9 participants. But now all of you are well versed with AP info, then epidemiological methods, sample size. Have you calculated sample size with AP info? Have you used that software for calculation of the sample size?
Excuse me, sir. Excuse me, sir.
Yeah.
Yeah, Neha God, sir. I am working as a faculty of anatomy in the Department of Country.
Yes, there is some interference.
Yes, sir. Yes,
Please
sir.
may repeat, please.
Sir, I wanted to ask one thing that I have planned a study on fibula only, but whatever fibula are available in the department, so the sampling technique will be just the convenience sampling, and the study will be the parametric observational study only. So, is it okay?
Just repeat, what is your variable?
So variables are the different parameters at the lower end of the fibula.
What is the topic?
So topic is the study of to study the lower end of the fibula and its clinical significance.
Lower end of
Fibula bone,
fibula. Yeah, lower end of fibula and.
its clinical significance.
Mm-hmm.
So sir, it's a parametric study, observational study, and the
જમવા
sampling.
ઓનલાઈન ક્લાસ ચાલે જ ને 9 વાગે પતશે પછી જમવા.
What do you want to find out of from that end of the fibula?
So different parameters and what is the range on the both side, right and left side, I want to compare. Like
So-
I have got some articles like some studies are there in the central India, so I can compare with those studies. Like I am now studying on the South Indian fibulae, so I can compare those results. So these all are my objectives.
But what is the purpose? You want to find out the diameter, you want to length, or you want to find
Yes,
out
sir.
with
Yes, sir. Yes, sir.
yeah,
So
you want to
actually,
correlate, you want to correlate with the age or male female ratio. You want to you should have something in mind. Suppose if there is nothing in mind, you want to go for absolute science. That you want to postulate that the fibula size is this, something like that. So even if you want to do it, convenience sample is not good.
Okay,
Because what is your population? From where? What do you want to postulate? At least you want to study at least 1,000 people or 2,000 people.
so my study is on bones only.
Bones only, I agree.
Okay,
But the
sir.
bones of human being, for example, right?
Yes, sir. Yes,
But
sir.
of which age?
Which age? But sir,
Yeah.
sir, but we can't estimate age from whatever bones are available in the department, no, sir?
So your population is available bones in your anatomy department. That study will not be much helpful. So instead of that, you say that you want to take the bones of the 40 medical colleges and you want to find out the various parameters related to the fibula. Because one department may have around 10, 20 or 30 fibula.
Yes,
So
sir.
if you measure only your 30 fibula, that is not going to help anyway. Instead of why not to involve, let's say 40, 50 medical colleges, and they will have a 30, 40 fibula. They give a number to the fibulas, and then usually in such cases, your sample size would be around at least 100, but it may be around 400 when you want to talk about the population. And your sample size will depend upon, if you're measuring in terms of centimeter, how much difference you want to allow, 0.5 centimeter, 1 centimeter, 2 centimeter. Based on that, you will be writing your sample size. And then your study will be useful. Otherwise, you take your only the fibula of your department, you measure it, that will consider as a pilot study, but not the research study.
Yes, sir. Not for research actually.
Yeah, for pilot study is
Yes,
okay.
sir. For pilot studies to use.
That is
Yeah.
fine.
Yeah,
But
sir.
then
so for
our
that-
objective should be go for the other research study. And other thing is fibula in the live individual also, you may not be able to measure diameter, but at least length you can measure.
Yes,
So
sir.
age-wise length of the fibula, if you take that kind of thing in the live human being, then that research study will have some more validity and you will be appreciated a lot. So anything else? Dr. Harsh of the chair, Bhavna, Dakate. It's not that you can discuss right now only. So we'll have a second batch also, and you can always, our group will continue. And some of you might have started looking at the our education platform. In our education platform, we'll be updating within 10 to 15 days. So you'll have find more files, etc. Even if you come out of the WhatsApp group, educational platform will be there, and you can have your folder and keep all this files safe. I wish that all of you at least conduct one small randomized control trial, all right, to see the effect of whatever you want. Anyone else? So next time, before we start next session, all of you should be clear about your one project proposals, and you should come up with the various tables using AP Info. So I think if there is no other questions, we can end
Good
up this.
evening, sir.
Good evening.
Sir, I'm also from anatomy department. I was thinking about a comparative study on the fixatives that we use, such as 10% formalin and the Boyne's fluid for the immunohistochemical studies. So I was planning to take fresh specimen which are fixed in 10% formalin as well as Boyne, or the moment I get the specimen, like within 24 hours. And some specimen I will keep in both the 10% formalin and the Boyne's fluid for 3 months of period. Then other specimen I'll keep for 6 months of period, and the same specimen for one year of period. I just want to know the efficacy of all fixatives that we are using for IHC, and if the formalin is the better choice or the Boyne's fluid is the better choice when we do the IHC studies. So even though this is a rough map of what I'm telling you, do you have any suggestion about the study, how to go about it?
Instead of 3 months, 6 months, 9 months, etc., there could be this kind of thing also. You keep it in formalin till it is getting bad, and other also still it is getting bad. So rather than see 3 months, 6 months, evaluate, you can evaluate at any monthly interval. That will be fine, whether they are preserved properly or not. But allow them to stay there as long as they can. And because number of days will be much better than the number of months as far as the calculation of mean days, etc. is concerned. And then you, instead of comparing only 2 things, if you have another 2-3 things right now.
I do have other fixatives going on.
So if you take, when you have a choices, instead of going for 2 or 3, you can go for that. And the same study, I repeatedly tell you that you try to involve other medical colleges. Now I have a network of more than 3,500 doctors. In anatomy group, there will be 150 people. In a physiology, there will be 110.
Exactly.
So in that NMC discussion group, you put forward your formula that you want to do this project, right? So let others also join. Right? Then we can discuss out and then go for this study. In this case, which test you are going to use it?
Sorry?
Which statistical test you will use at the end of your study?
So that is what I am also not.
It will be simple standard of difference between the two mean, whether it is a significantly different or not. You just go for your data collection like this. The type 1, type 2, type 3, type 4, you are around 8 to 10 samples, right?
Yeah.
And then number of days, 10 days, how many days they survive. And the others also how many it survive. So in database, it is very important to understand that the first column is sample A, B, C, D, like this. For each sample, for formalin, what is the thing? And then for another solution, what is the number of days? And if you go for this, at the end of your study, you will be able to find out mean days for both. And then you will be directly, the AP Info will tell you. So once you prepare the database on the pilot, send me your Excel file and we'll study how to analyze in AP Info.
Okay, sir. Yeah, thank you.
Anyone else? So let's close it. If any question is there, last few minutes. Who is the Nirmal? Someone Nirmal has joined. Okay. Let's close it now. Thank you.